Hello viewers, the topic for today's discussion is program linking. What are the goals? The goals, or you can say the goal is to resolve the problems with EXTREF and EXTDEF from different control sections. Just recall when we are discussing the control section. In that lecture, we had discussed EXTREF and EXTDEF. EXTREF is a pseudo instruction that gives the information what are the symbols that are used in that control section but that are defined in another control section. EXTDEF means what? It just gives the information. This is also a pseudo instruction. It just gives the information that what are the symbols that are defined in the current control section, and we will use the modification record for both relocation and linking. Let's take an example. Here I am just taking an example. In this example, there are three control sections. One is program A, another is program B, and third one is program C. And we want to see that how we are getting the object program for these control sections. And these control sections, as you know that the control sections are assembled individually. For example, in this case you can see here this program starts from 0, and in EXTDEF this one list A and list B are written. That means what? These are the symbols list A and list B that are defined in this control section. You can see here list A is defined here and end A is defined here. This is end A, not list B. This is end A. End A. EXTREF, that means what are the symbols that I am referring here from the other control sections, like in this case list B, end B, list C and end C. These are the symbols that are defined in another control section, but I am referring these symbols in this control section. Now basically our task is what? How to find out the value of list B, end B, list C and end C during the linking. You can see here I have taken a snapshot, and in this case I have just taken some instructions that are required to understand the concept of program linking. Here you can see at 0020 address the symbol is ref1. The instruction is LDA list A. LDA list A, just apply format 3 instruction here of SICXC, format 3 here, and find out the object code corresponding this. There is direct addressing, you can see here, so NI will be 11. Now the next one is at 0023 address reference to plus LDT list B plus 4. In this case you can see here I don't know the value of list B. I just assume that the value of list B is 0 here, and 0 plus 4, that becomes 4. Just put this 4 in the address field of this instruction, because this is format 4 instruction. You know that in format 4 instruction how we are putting in the format 4 instruction. The format 4 instruction is like this: opcode by 6 bit, then N, I, X, B, then P, then E, and then address by 20 bit. Then address by 20 bit. So now in the field of address just put the value 4, because I don't know the value of list B here, so I will take the list B as 0 here. 0 plus 4, that becomes 4. Just put here 4 in the field of address. You will get this object code. At 0027 address, the instruction is reference 3 LDX has end A minus list. Just calculate the value of this expression end A minus list A. As we know that end A and list A are defined in this control section, so we will get the value of end A minus list A. You can see here end A is what? 0054 and list A is what? 0040. When you subtract this list A in end A, you will get 0014. And just put this instruction in format 3, you will get this object code. Now the next instruction is list A EQ asterisk. You know that the current address becomes the value of list A. End A EQ asterisk, the meaning of this instruction is that the current address becomes the value of end A. Now the next instruction is at address 0054 reference for word end A minus list A plus list C. We know that we don't know the value of list C, so we will take the value of list C as 000000 in one word. And we know the value of end A, that is what? End A value is 0054, so this one becomes 0054. And list A becomes 0040. When you subtract that, you will get 000014. Now, the next instruction is at address 0057, reference 5, word end C minus list C minus 10. I don't know the value of end C, it will be 0. List C, it will be also 0. 0 minus 0, that becomes 0. Minus 10, that becomes minus 10. In this case, this 10 is written in decimal, just put it in binary. It will be like this one, 0, 1, 0, 1 and all 0 in one word. That means this will be 0, 0, 0, 0, then 0, 0, 0, 0. This is 10. And now our task is to find out minus 10. That means just find out the 2's complement of this. That will be what? 0, 1, this will be 1, 0 and this will be 1, 1, 1, 1, 1. So it becomes 1, 1, 1, 1 and this will be also 1, 1, 1, 1. So you can see the 2's complement becomes F, F, C. Just put it into the one word. This will be what? FF, FF, F6. Sorry, this is 6 here. FF, FF, F6. And now you can see here when you put this in one word, this will be all 0 here and that becomes 1. So it will be FF, FF, F6. Now the next instruction is at address 005A. That is what? Word end C. I don't know the value of end C because it is written in EXT ref. List C, same. I don't know the value of list C. Plus list A minus 1. I know the value of list A. This becomes 0 minus 0, that becomes 0. 0 plus list A is 0040. Minus 1, that becomes 003F. Just put in one word, it will be 00003F. The next instruction is at address 005D, reference 7, word end A minus list A minus in bracket end B minus list B. I know the value of end A, that is what? 0054, 0054 minus 0040, it becomes 0014 and I don't know the value of end B and list B. So we will take the value of end B and list B as 0. 0 minus 0, that becomes 0. 0014 minus 0, that becomes 0014. Just put in one word, that becomes the object code corresponding this instruction. Now the next instruction is at address 0060. You can see here 0060. Reference 8, word list B minus list A. And we don't know the value of list B because it is written in EXT ref. So it will be 0. 0 minus list A, and I know the value of list A, that is what? 0040. That means it becomes what? 0 minus 0040. So we have to find out the 2's complement of 0040. That will be the value of this. When you find out the value of 0040, 0040, that will be what? 0. and if I just put 4 in binary, it will be what? 0, 1, 0, 0. The 2's complement of this will be what? 0. This will be 0. This will be 1 and this will be 1. So it will be C. And this will be F, 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 F. So the object code will be FFC0. It is written here. FF, 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 C0. Now our task is to write the object program corresponding this control section. First one is header record H, then the name of the program, program A, then the starting address of the program, that is 0, so it is written here 0, 0, 0, 0, 0, 0. Then the size of the program, you can see here when you want to find out the size, the last address is 0060 and this is one word, that means 3 byte, so the next address will be 0063. The next address will be 0063, 0063 minus 0, that becomes 0063. So the size will be 000063. Now we have to write the define record. Define record means what are the symbols that are defined in this control section. That are what? List A and end A. How we are writing the define record? We had discussed in how to write the define and refer record during the control section discussion. In this case, how we are writing? First we have to write list A, this one symbol. Then what is the address of list A in this control section? That is 0040. So it is written here 000040. Then end A, this one end A. Then address of end A, that is 0054. It is written here 000054. Then we have to write refer record. In refer record, we have to write only the symbols that are referred in this control section, that are what? List B, end B, list C, and C. So it is written here list B, end B, list C, and C. Now, after this, I have to write the text record. You can see our text record starts from the address 0020. So here it is written 000020. Then we have to write the size. There are some symbols here. I am not considering those instructions here that are written. So I am writing here the comment only dot. You can see here the size of this text record will be 10 byte. So the size is 0A. And we have to write the object code. This one, and this one. So it is written here. You can see. Now, our next text record is start from 0054, 000054, this one. What is the size of this text record? You can see here 3, 6, 9, 12, 15. So 0F, that is the size of this text record. Now we have to write the object code, this one, and this one. It is written here, you can see here. Now our main task is to write the modification record that are required when I am executing this control section. You can see instruction by instruction. I am looking here. Just look at this instruction at address 0023. You can see here in this instruction there is no modification required because this instruction is written in format 3. When you see the instruction 002 at address 0023, it is written in format 4 and we have taken the value of list B as 0. That means we have to add the value of list B in this address field to find out the exact value of list B plus 4. You know that what is the concept of modification record? When this program will be loaded in main memory for execution, these modification record, according to this modification record, your loader will change the values that are written in your object program. That means what? You know that when we are just finding the object code corresponding this instruction, we had taken the value of list B as 0. It means what? In the modification record, I had to add the value of list B. I had to add the value of list B. Where it will be added? Because I had taken this 4 in the address field, so this list B plus 4 will come in the address field. So it will be added in the address field of this object code. And you can see here the address field in format 4 is of 5 nibble. That means I have to add the value of list B in these 5 nibbles. Now, what will be the address of modification record? Because this instruction starts from 0023, so 0023 is the address corresponding 77. So the address corresponding 10 will be 0024. So I had to write the modification record at 0024, 000024, this one. In how many half bytes? I had to add the value of list B in 5 half bytes. That means in 5 nibble. So it is written here 05. And what I had to add here to find out the value of this expression? List B. So it is written here plus list B. Now the next instruction, this one. You can see here, this instruction provide absolute value. Because when I am subtracting list A from end A, we will get an abstract value, or you can say absolute value, sorry. We will get an absolute value because this instruction is an absolute instruction. This instruction is an absolute instruction. Okay. So, in this case, there is no need to add any value. There is no need to add or subtract any value. Now, the next instruction is written at 0040. There is no need of modification record. Same is for 0054. There is no need of modification record. Just come to the instruction 0054. You can see here, I know the value of end A minus list A. And end A minus list A will give you an absolute value. It will give you an absolute value. So this 000014 is an absolute value. And now in this value, I had to add the value of list C. I had to add the value of list C. This one. So you can see here, this instruction is written in word. That means I had to add the value of list C in one word. So in whole object code. So the starting address, or you can say the address of modification record will be 0054. So it is written here 000054. In how many half bytes? 6 half bytes. You can see here. Because I had to add this value of list C in whole object code. So it is written here 06. And here I had to add the value of list C. So plus list C. Now our next modification record, you can see here at 0057 address, this is written in word, end C minus list C. I don't know the value of end C as well as list C, but I know the value of minus 10. So what we have to do? We have to add the value of end C and subtract the value of list C to get the exact value of this expression. So at 0057 address, 0057 address, 06, that means we have to add in whole object code. You can see here this is written in word. That means this is the value. I have to add end C and subtract list C in this value. 06 plus end C. And in the next modification record, it is written at address, same address 000057, 06 minus list C. Now consider the next instruction at address 005A. It is written as end C minus list C plus list A minus 1. Now you can see here, in this case, I have to add the value of end C, subtract the value of list C, and I am using here relative value of list A. You can see here. Just compare this instruction list A minus 1 and this instruction end A minus list A. In end A minus list A I am getting the absolute value. But when I am considering this one list A minus 1, in this case we are getting the relative value. That means what? When this program will be loaded in main memory, at that time I have to add the address of this program where it is start in the main memory. Because you know that when this program will be loaded, suppose that this program will be loaded at address 5000 in main memory. At that time, the value of list A, becomes 5040. That means here I am taking the value of list A as 0040. In modification record, I have to add the value of program A. I am repeating one more time. Here I am using the relative value of list A. That is what? 0040. When this program will be loaded in main memory, the address corresponding program A becomes, suppose that 5000. In that case, the list A becomes 5040. And here I am taking the value of list A as 0040. That means what? To get the exact value of list A, I have to add 5000 here. So what will be the modification record here? That will be plus and C at address 005A 06 plus and C minus list C plus program A. This modification record is written to get the exact value of list A. Now the next address is 005D. You can see here in 005D I am getting the absolute value and A minus list A. So this is the absolute expression. So this value is written and it will not change at the time of relocation also. Now our task is to subtract and B and add list B. Just open this bracket, you will get minus and B plus list B. So what will be the modification record at 005D address? 06 minus and B and plus list B. Now our next instruction is at address 0060. That is what? List B minus list A. In this case you can see I have to add the value of list B and here minus list A is the relative value. That means I have to subtract the program here to get the exact value of list A. You can see here when I am putting here list A, that is what? 0040. When this program will be relocated, suppose that it is relocated at address 5000, then in that case the value of list A becomes 5040. So I have to get that value. That's why this modification record is written as plus list B minus program A. Now consider the next control section, that is program B. Starting address is 0. Here the symbols that are defined in this control section are list B and NB. And the symbols that are referred here are list A, NA, list C and NC. At address 0036, the instruction is written in format 4. And here I don't know the value of list A, so we will take the value of list A as 0000. Just put the value of list A in the address field. In format 4, you will get this object. Now the next instruction is at address 003A, that is what? LDT list B plus 4. Now here you can see I can find out the value of list B because I know that list B is written in ext def section. What is the value of list B? That is 0060 plus 4, that becomes 0064. Just put this instruction in format 3, you will get this object code. Now the next instruction is at address 003D, that is what? Plus LDX has and A minus list A. I don't know the value of and A as well as list A. Just put it here 0 and put this instruction in format 4, you will get this object code. Now for the instruction for the address 0070, the instruction is word and A minus list A plus list C. I don't know the value of and A as well as list A as well as list C. Just put these values as 0, you will get 000000 in one word. At address 0073, the instruction is, or you can say the expression is and C minus list C minus 10. Here I don't know the value of end C as well as list C. I know the value of minus 10. Just put it here. Just find out the 2's complement of 10. That will be what? F6. At address 0076, the instruction, expression is end C minus list C plus list A minus 1. I don't know the value of end C, list A. I know the value of 1. Just convert 1 into the 2's complement. You will get FF. At address 0079, the expression is end A minus list A minus in bracket end B minus list B. Here I don't know the value of end A list A, that becomes 0 minus I know the value of end B. What is end B here? 0070 and list B what? 0060. It becomes 0010 and minus 0010. Just find out the 2's complement of 0010. You will get this value. At address 007C, the expression is list B minus list A. I know the value of list B. That is what? 0060. So it will be 000060 and we will take the value of list A as 0. Now, our task is, now you are able to write these text records and this define record, refer record and this one, header record. Here I will discuss the modification record. Consider this address 0036. Here I have written the value of list A as 0. That means I have to add the value of list A to find out the exact value of this object code. Now you can see here the list A is written in address field. So I have to write the modification record. You can see here this is at address 0036 and this one is at 0037. So in the 5 nibble which start from 0037, I have to add the value of list A. That's why it is written here 0037 05 plus list A. This one you can see here. Now at address 003A, this instruction is written in format 3. There is no problem in this instruction. At address 003D, this instruction is written in format 4 and I have taken the value of end A and list A as 0. So I have to add the value of end A and subtract the value of list A. At which address? You can see here 05 is written at address 003D. 10 is written at address 003E. So I have to write the modification record at the address 003E and in 5 nibble, that means in address field, I have to add the value of end A and subtract the value of list A. So that's why it is written here. You can see 003E plus end A minus list A. Now at address 0070, then expression is end A minus list A plus list C. Now you can see here end A I have taken 0, list A 0, list C 0. So what we have to do in modification record, because I have to add these values and subtract these values in the whole object code. So this modification record will start from 0070, this one, plus end A minus list A plus list C. Now at address 0073, the instruction is, or you can say the expression is end C minus list C minus 10. Here I have to add the value of end C and subtract the value of list C. So this modification record is written at address 0073 plus end C and this one is minus list C. This is minus here. Minus list C. Now the next instruction is written at address 0076. That is what? Basically there is an expression. Here I have to add the value of end C, subtract the value of list C and add the value of list A also. So the address of this modification record will be 0076, this one, plus end C minus list C plus list A. Now the next instruction is at address 0079, that is what, end A minus list A minus in bracket end B minus list B. And I have taken the value of end B minus list B. So I have to only add the value of end A and subtract the value of list A. It is written here, you can see at address 0079 plus end A minus list A. Now at address 007C, you can see here, I know the value of list B, but that value is relative value. It is not an absolute value. So what we have to do here? We have to add program B to find out the exact value of list B and subtract list A. So it is written here at address 007C, add program B and subtract list A. Now our next control section is program C. And it is written at address 0. These are the symbols that are defined in this control section, list C and C. And these are the symbols that are referred in this control section, that are what? List A, list B and end B. Now consider the first instruction at address 0018, that is what? Written in format 4, and I don't know the value of list A, so just take it as 0, put in the address field, you will get this object code. At address 001C, the instruction is plus LDT list B plus 4. Here I don't know the value of list B, so it will be 0. Only I know the value of 4, so just put 4 in the address field, you will get this object. Next address is 0020. I don't know the value of end A, list A, so just take it as 0, put in format 4, you will get this object. At address 0042, end A minus list A plus list C. End A minus list A plus list C. I don't know the value of end A as well as list A. Here I know the value of list C. What is the value of list C? 0030. So the object code becomes 000030. At address 0045, end C minus list C, I can find out the value. End C minus list C minus 10. That means we can find out the whole expression here. So the object code becomes the value of this expression 000008. At address 0048, that is what? End C minus list C plus list A minus 1. I know the value of end C and list C, but I don't know the value of list A. So we will take it as 0. Find out this value, end C minus list C, that is 0012, that will be the absolute value. Minus 1, you will get this object. At address 004B, end A minus list A, I don't know the value of end A minus list A. Here also I don't know the value of end B and list B, so it will be 0 only. At address 004E, list B minus list A, I don't know the value of list B as well as list A, so it will be 0 only. Now, what will be the modification record now? Here now you are able to write these records. You can see here the first instruction start from 0018, that is written in format 4. What we have to do here? You can see here the address corresponding 03 is 0018 and corresponding 10 is 0019. So at address 0019, what we have to do? In the 5 half bytes, we have to add the list. So it is written here. It is address 0019, 5 half bytes plus list. Now, the next instruction is at address 001C. That is what? List B plus 4. I don't know the value of list B. What we have to do? At address 001C, this 77 is written. At 10 is written at address 001D. So at address 001D, we have to add the value of list B in the 5 half bytes. This is written here. Next instruction is at address 0020 plus LDX and A minus list A. What we have to do here? This 05 is written at address 0020. 10 is written as address 00121. So at address 0021, what we have to do? Add the value of end A and subtract the value of list A. It is written here. Now the next instruction is at address 0042. That is an expression. What we have to do here? end A, we have to add end A. We have to subtract list A in this value. As well as we have to add program C, because I am using a relative value of list C, not an absolute value. So what will be the modification record here? Plus end A minus list A plus program C. Now the next instruction is at address 0045, that is what? And C minus list C minus 10. You can see here I am getting the absolute value, and C minus list C will provide an absolute value. So there is no need to write the modification record in this case. At address 0048, I am writing here and C minus list C. This is an absolute value. There is no need to write. But we have to add the list A. We have to add the list A. So at address 0048, list C is added. List A is added here. At address 004B, the instruction is AND A minus list A minus in bracket AND B minus list B. What we have to do? We have to add AND A, subtract list A, subtract AND B, add list B. At address 004B, it is written here. AND A minus list A minus AND B plus list B. Now the next instruction is at address 004E. That is what? List B minus list A. I don't know the value of list B as well as list A. So what we have to do here? Add the value of list B and subtract the value of list A. So it is written here. Plus list B minus list A. Now in the next lecture we will understand that how the linking procedure linking is performed. Thank you so much.